Happy Monday of the shortest week of our whole school year. I'll see you guys tomorrow. This is just a brief tutorial on how to collect data for this lab. So this lab explores the relationship between weight and mass, and we need to measure both weight and mass to find this relationship. We're going to measure weight, which is the force of gravity. So force of gravity is weight, weight is force of gravity. They're the same thing. They mean the same thing. So we're going to measure that with a spring scale. There's two different spring scales that you have a choice of, and they are a little bit different just in their range. I mean, they're obviously different colors. So the green spring scale has a range of 5 newtons. So if you have something that's really small, 5 Newton force or 5 Newton range spring scale is probably the best. If you have something that's a little heavier, you can use the red spring scale, which has a range of 0 to 20 newtons. So we'll do that by just hanging our objects on the spring scale. And if you have trouble hanging the object, there's some string up front. You can tie a little string around the object so you can hang it. So before we do that, we need to make sure it's zeroed. So you can pull this little silver tab to make sure your spring scale reads 0 when it's hanging with no force. Then you place your object on it and you can read the force. So if 0 was at the middle of my little silver marker, then whatever force the middle of this reads, which to me is about 4.5 newtons, is going to be the weight. So you record that weight of the clamp, and then you just need the mass of the clamp. You can find the mass with a triple beam balance if you're particularly interested in that. They're fun. You want to make sure they're zeroed to start. And then the way these work is you place a mass on here, and then these other known masses at set distances kind of find an evening out or a balance. So this is a balance. It balances the mass of this spring scale with the mass here. And I say mass because gravity does affect these, but it affects them both. So it affects them both in the same way, so it kind of has no effect. This should still work if gravity changes. Another way to do it that's more modern, actually a little easier, is with a digital balance. There's 2 digital balances we have. This one is 2,000 gram, has a 2,000 gram range. So that's for our heavier objects. So you would just make sure it's zeroed, make sure there's no E, and you see a 0, and place your object on that. Make sure it's not resting on the table or anything like that. And you do that. So we get about 483 grams. For this lab, it's important to convert grams to kilograms. So there's 1,000 grams in every kilogram. So 483 grams is going to be 0.483 kilograms. So once you have the weight and the mass of your 10 objects, weight in newtons, mass in kilograms, you'll go into the computer lab and you'll graph that data. So we'll put weight on the y-axis, mass on the x-axis, and then we want to fit a trend line with that, and I'll attach the video of the Excel tutorial to the assignment so you can watch that video if you have any questions. Feel free to message me on Schoology, and this isn't going to be due until the following Tuesday, so there'll be some time for you to ask me questions. Have a great day, and I'll see you tomorrow.